specific yield. We have seen. Good morning, friends. Up till now, we tried to understand the three main parameters of the aquifer, maybe a confined aquifer, maybe a unconfined aquifer. Those are the porosity, specific yield, and the specific retention. We have also tried to derive that porosity N is equal to specific retention SR plus SY, specific yield, from the total voids is equal to the water that has been taken out easily plus the water that has been retained. So volume of the voids is equal to volume of the water that is yielded or taken out plus volume of the water that has retained. From this property, from this formula, we try to derive that porosity is equal to specific yield plus specific retention. Some simple numericals are there that today we will start with, and then we will move to another properties and the parameters of the aquifer. As has been given here, I have told you, therefore, to enhance or to enlarge your imagination, I have told that aquifer will have a large area, will be quite in kilometers of the length, kilometers of the width, and meters of the depth, so that you should understand the volume of the aquifer, how much quantity the aquifer can hold, maybe a confined, maybe a unconfined. So from that prospect, we will try to understand this numerical. An aquifer is, it has got the area of 80 hectares. The water table is lowered by 10 meters over the whole area. As the water table has been mentioned, so therefore this aquifer must be a unconfined aquifer. Otherwise piezometric head has been used. I just try to confirm you the relation between water table and unconfined aquifer. Piezometric head, again a representation of the water table in the confined aquifer. So piezometric head related to the confined aquifer. So in this aquifer whose area is 80 hectares, the water table is lowered by 10 meter over the whole area. The water table may be lowered by through the wells, by dewatering, or may be lowered due to the evaporations, etc. If the porosity of aquifer is 30%, so N value is given as 30%, and the specific retention SR is 5%. Calculate the amount of the water that has been actually drained out from the aquifer. A very simple numerical. Just try to understand the basics. We have derived this equation that porosity is equal to the specific yield plus specific retention. We have been given the porosity as 30%. We have been given the specific retention as 5%. So from this equation, we can find out the specific yield. So therefore, specific yield is equal to porosity minus specific retention. 30 minus 5, that is 25% of the water, of the total water available in the aquifer, can be very easily taken out by lowering the water table by 10 meters. Okay, so this is the significance or understanding from this numerical. So we know the formula that specific yield is equal to the volume of the water drained, means volume of the water that has been taken out easily, divided by volume of the total aquifer mass. Okay, so therefore we wanted to find out this volume of the water that has been drained out. It has been asked to us, calculate the amount of the water that is actually drained from the aquifer. So we don't know this, but we know specific yield that we have found out just now, 25%. And we can find out the volume of the aquifer mass. We know the area of the aquifer. We know the depth of water that has been taken out, 10 meters. So area into depth will be the volume of that aquifer. Okay. So therefore, thus the volume of the water drained divided by volume of the aquifer mass, that is 80 multiplied by 10, and specific yield is equal to 0.25. Therefore, the volume of the water drained is equal to specific yield multiplied by the specific yield multiplied by volume of the aquifer. So therefore, specific yield is equal to 0.25, that is 25 upon 100. 25% we have worked out. And volume of the aquifer is 80 meters is its area, and 10 meter is the depth of water that has been taken out. So 80 multiplied by 10, that is area multiplied by depth is the volume, multiplied by specific yield, यानी इतना जो वॉल्यूम है, इतने वॉल्यूम का 25% उसमें पानी निकाल सकते हैं उसमें, यानी टोटल वॉल्यूम का वाइड्स कितना है कि 25 + 5, यानी स्पेसिफिक रिटेंशन 5% है और 25% yield है, specific yield है. The 25 + 5, that is 30% is the volume of the voids, but we are not interested in that. 30% is given also here. The porosity is given here. So therefore, the volume of the water drained is equal to 25% of the volume of the aquifer. 200 hectare meters is the answer. Very simple, but sometimes such simple numericals are asked. Again, second type of the numerical. This is related to confined aquifer. The confined aquifer is 40 meters thick. Okay. They have not given the thickness of the unconfined aquifer, because in the earlier numerical, what they have given the lowering of the water table 10 meters. So therefore, we have assumed the area multiplied by the water table lowering depth is the volume of the aquifer. But here, as it is a confined aquifer, so both sides of that confined aquifer are hard rock impermeable strata. Therefore, that aquifer will have a depth or thickness, that is the 40 meters. Its area is 100 hectare meters. The piezometric head is lowered by 5 meters. Okay, here no water table word is used. The piezometric head, because the water in the confined aquifer is always under pressure. So the piezometric head is lowered by 5 meters. So therefore, find out the water that has been taken out from the aquifer. Simple parallel example. Determine the volume of the water released or taken out from the aquifer. Take the storage coefficient. Here the storage coefficient they have given S is equal to 2 into 10 raised to -4. So amount of the water released is equal to the storage coefficient S multiplied by area of the water aquifer multiplied by decline of the piezometric head. Okay. So 2 into 10 raised to -4 into the area of 100 into 5 meters is the decline of the water piezometric head. Therefore, the total is 1000 into 10 raised to -4 hectare meter, or 1000 meters square, meter cube it should be, or 0.1 hectare meter is the quantity of water that has been released. Okay. So these types of the numericals are there. We will try to understand the concept of the storage coefficient in the discussion to come. Now we will be moving on to understand how the water flows or moves into the aquifers. Maybe a confined aquifer, maybe a unconfined aquifer. Numerous studies has been carried out over that, and one postulate or one theory or one theorem that has been given by Mr. Henry Darcy in 1856 has been found to be very correctly correlate to the velocity of the groundwater through the aquifers. in which he states that the velocity or the water flow, velocity or the volume of the water, because the volume is equal to velocity multiplied by the cross sectional area of the aquifer. So velocity of the groundwater flow is related to the hydraulic gradient, that is the slope of the water table. A very important word here, the hydraulic gradient means we always know in terms of our fluid mechanics or the hydraulics, hydraulic gradient is the gradient of the hydraulic energy line. Okay, that hydraulic energy which is equal to the water head plus the velocity v square by 2g plus the potential head. Okay, you must be knowing that velocity gradient or the velocity at one point and velocity gradient at another point, some distance apart. If we joined that velocity at both these points, then that line gives the velocity gradient or the hydraulic gradient. Hydraulic gradient is in our groundwater hydrology, the hydraulic gradient is related to the slope of the water table. Okay, so what Henry has found, or Henry Darcy has found, that the velocity through the groundwater aquifer is correlated, again like the fluid mechanics or the hydraulics, is related to hydraulic gradient, that is the slope of the water table. Okay, which again consists of the water head plus the kinetic energy or v square by 2g plus the potential energy, that is the height of that water from certain datum. So hydraulic gradient, and it is as the water flows, it does not flow like a free water on the surface of earth, that is the open channel flow, or through the he has correlated this flow through the soil parallel to the water flowing through pipes. Okay, Mr. Darcy has correlated or stated that this flow of the water through the soil pores is very parallel to the water flowing through the pipes. So the water flowing through the pipes, we consider the friction as one of the component. So in the same way, he has correlated that friction with the coefficient of permeability of the rock or the sediment through which the water is flowing. Because the water is flowing through the pores of the soil, so every time that flowing water has to overcome the friction with the soil particle. So therefore that frictional coefficient, he has named it as a coefficient of permeability of the rock or the sediment through which the water is flowing. So in short, what Mr. Darcy has stated, that the velocity of the groundwater, velocity of the water flowing through the aquifer is proportional or is the function of the hydraulic gradient and the coefficient of permeability of the rock or the sediment through which the water is flowing. And the coefficient of permeability, he has called it as the hydraulic conductivity, is determined by the permeability of the soil, the density of the soil particle, and the viscosity of water. Okay, these three are important for the hydraulic conductivity. How much pore sizes big are there in the soil structure, so that will decide the permeability flow of the water. Bigger the pore sizes, bigger the voids, more will be the permeability. Density again, more the density, lesser will be permeability. Lesser the density, more will be the permeability. And the viscosity of water, because at certain temperature or at different temperature the viscosity of water changes. In colder temperature viscosity is more, in the hotter temperature or hot temperature the viscosity is less. So all these three parameters control the hydraulic conductivity or the coefficient of permeability, and the another parameter, that is slope of the water table, gives the hydraulic gradient. This has been stated by Mr. Henry. In short, the Darcy's law of flow of water in the saturated soils. In some respects, groundwater reservoirs are very similar to the surface water reservoirs. That is, the aquifers are very similar to the reservoirs above the soil surface, over the ground. They also have a particular capacity and must have a discharge and recharge like the reservoirs in the soil above the ground. So the flow of the water in the saturated zone of the soil, that is the aquifer, is governed by Darcy's law, and this law states that the velocity of the flow through the porous media is proportional to the first power of the hydraulic gradient. This is very important. You should note down that Darcy's law states that the velocity of flow through the porous media, that is through the aquifer, is proportional to the first power of hydraulic gradient. And what is hydraulic gradient? He has stated that the difference in level of the groundwater table can be treated as the hydraulic gradient, as has been shown here. You can see from the soil surface, this is the groundwater table, dotted line. This groundwater table is at a height of h1 from top of the soil, and at certain distance or at certain length L, the height is h2. So h1 minus h2 is the difference in the water table, okay, divided by L is the hydraulic gradient. So the hydraulic gradient is the slope of the water table, as has been stated by Mr. Darcy, and also from the hydraulics point of view also it is the correct. As you can see, h1 minus h2 upon L. L is the difference between the two water tables which has been observed. So he stated that the velocity of flow through the porous media is proportional to first power of the hydraulic gradient, and he has expressed it as V is equal to velocity is equal to K into I. I is the hydraulic gradient, that is difference in water table divided by the length. V is velocity and K is the constant, or the discharge through the aquifer Q is equal to K, the constant, which he has called as the coefficient of permeability. A is the cross-sectional area of the aquifer. I am using the word cross-sectional area of the aquifer, not the top area of the aquifer. So cross-sectional area of the aquifer, and I is the hydraulic gradient, that is h1 minus h2 upon L. L, as has been shown here. I am trying to support this slide with that picture or with that clipet already shown to you to understand the meaning of the hydraulic gradient. H1 again is the top height or top depth from the earth surface to the top of the groundwater table at one location. H2 is another depth of water of the groundwater table from the distance L from the first one H1. So H1 minus H2 divided by L is the hydraulic gradient. So where Q is the quantity of water flowing through the soil, K is the constant. It depends upon the porosity and permeability of soil, is called as the coefficient of permeability or hydraulic conductivity of the material. Very important word. Two words are there, coefficient of permeability or hydraulic conductivity. In exam, they may use the word hydraulic conductivity, so you should not be confused. You must know that is hydraulic conductivity is nothing but the coefficient of permeability. Again, this depends on what? It depends on the density of the soil, it depends on the permeability of the soil, okay, and also depends on the piezometric head or the water table, etc. We have seen earlier. And I is the loss of the head per unit length or the hydraulic gradient, and A is the cross-sectional area of the aquifer. So we have seen that mathematically I, or the hydraulic gradient, is equal to H1 minus H2 upon L. AV is the velocity in soil, A is the cross-sectional area through which the water is flowing. So so we should understand what Mr. Darcy has assumed to make it very simple to find out the discharges or velocity through the soil. He has assumed that there are number of the capillary tubes in the soils through which water passes, and he has considered it as very similar to as the water flowing through the pipes. So the first thing he has assumed that as the water flows through the pipes under pressure, in the same way the water flows through the capillary tubes which are interconnected to each other through the soils. And very second important assumption he has made, that the velocity through these pipes is as good as laminar flow, and this laminar flow is proportional to the first power of the hydraulic gradient. Okay, so this velocity is very parallel to the velocity of the flow through the pipes, therefore this velocity is similar to laminar flow and is proportional to first power of the hydraulic gradient. V is proportional to the I, and V is equal to K into I. K is the constant which is called as the coefficient of permeability or the hydraulic conductivity. The flow obeying Darcy's law is definitely a laminar flow. Therefore, we will again move further. What are the other parameter which controls the laminar flow? It is the Reynolds number. Reynolds number can be used as an index to determine the range of the applicability of the Darcy's law. The Reynolds number is expressed as R is equal to V into D upon nu, where V is the velocity of the flow, D is average grain diameter, and nu is the kinematic viscosity of the fluid, nu, which is equal to mu upon rho. Mu is equal to dynamic viscosity of fluid, and rho is the density of fluid. You must have learned these things in your fluid mechanics. Reynolds number, its limits for the laminar flow, for the turbulent flow, okay, uniform, non-uniform flow, etc. So Reynolds number. So therefore, as this flow through this soil obeys Darcy's law, V is equal to K into H1 minus H2 upon L. So therefore, for it should also obey the Reynolds number. It should also follow the Reynolds number to certain values. So therefore, in natural and the artificial sandy medium of the uniform grain size of the aquifer, जो aquifer sandy medium से बना है, deviation of flow from laminar to the turbulent, यानी laminar flow से जब turbulent या velocity जब उसकी बढ़ती है, irregular flow होता है, non-uniform flow होता है, then the Reynolds value, the starts laminar to turbulent flow starts or converts for the values of the Reynolds number are between 1 to 10 depending on shape and range of the grain size. So therefore the groundwater flow is said to be same as the laminar flow, and hence obeys the Darcy's law. In tube wells also, where pumping means the wells which are in the confined aquifer, bore wells जिसको कहते हैं हम, where pumping rates are quite high, पंप से पानी निकालते हैं, ordinarily the flow obeys Darcy's law up to the well face. But at the well face, यानी पानी जब बाहर निकलता है, it may tend to become turbulent owing to high rates of the pumping. है ना, पंप की वेलोसिटी, पंप का जो पंपिंग रेट है वो यदि ज्यादा है तो वो लैमिनर टू टर्बुलेंट में कन्वर्ट हो सकता है. तो ये इतना हमें ध्यान में रखना है. हमारे हिसाब से तो बेसिकली ये डार्सीज लॉ के बेसिक्स और वो चीजें ज्यादा इंपॉर्टेंट है. The observation of the water table can be very easily and quite accurately done by noting the levels in the river, streams or the existing wells. फॉर व्हाट पर्पस? फॉर फाइंडिंग द हाइड्रोलिक ग्रेडियंट, है ना, हमने देखा H1 minus H2 upon L. H1 is the height of the water table at certain location. H2 is the height of the water table from the different location. The difference between the two locations is equal to L length. H1 minus H2 upon L is the hydraulic gradient. Now, how to observe this H1 and H2? So therefore, it has been said that it can be found out by noting the levels in the rivers. नदी में की रिवर एक जगह दो जगह की यदि लेवल हम देखते हैं तो उस पर से हमें पता चल सकता है. स्ट्रीम्स, एक आधी छोटी स्ट्रीम है उससे, या एग्जिस्टिंग वेल्स, ये बहुत इंपॉर्टेंट है क्योंकि वेल्स हमें ज्यादा एक्यूरेट ग्राउंड वाटर टेबल बताती है. ठीक है, फिर से यहाँ पे बताया गया है ये स्केच के माध्यम से कि द piezometric head at the two different locations and the hydraulic gradient, and the difference between these two levels is HL. So HL upon the length between these two will give you the hydraulic gradient. For the various soils, that is clay, sand, gravel and sand, sandstone, etc., quartz, the porosity values, the specific yield values, the hydraulic conductivity or the coefficient of permeability values, and the intrinsic permeability values are given here. Okay, so this is the table which gives the values of the different parameters of the soil structure of the aquifer is being given in this table to understand what are the differences. Clay में कैसी porosity कितनी रहती है, हाइड्रोलिक कंडक्टिविटी कितनी कम रहती है, कोएफिशिएंट ऑफ, लेकिन सैंडी सॉइल यदि देखा तो इसमें हाइड्रोलिक कंडक्टिविटी ज्यादा है, उससे ज्यादा ग्रेवली सॉइल जो है, ग्रेवल जिसमें है उसमें कंडक्टिविटी ज्यादा है, यानी यील्ड ज्यादा है इसमें. ठीक है, यानी ये देखिए आप, स्पेसिफिक यील्ड दोनों का 25, 22 ऐसा है. पोरोसिटी लगे तो क्ले की ज्यादा है, लेकिन वाटर फ्लो जो है, यील्ड जो है वो कम है उसमें as compared to gravel and sand combination. Okay, sandstone, और फिर जैसे और लाइमस्टोन, क्वार्टजाइट, ग्रेनाइट और कम होते जाता है ना, उसमें तो पानी का रिटेंशन या फ्लो रहता नहीं है ज्यादा. अभी और एक हम पैरामीटर समझने को जा रहे हैं, वो है ट्रांसमिसिबिलिटी और द ट्रांसमिसिविटी ऑफ एक्वीफर. ठीक है, बहुत इंपॉर्टेंट पैरामीटर है ट्रांसमिसिबिलिटी और ट्रांसमिसिविटी ऑफ एक्वीफर. हमने अभी तक के 3 देखे हैं, और एक अभी कोएफिशिएंट ऑफ परमेबिलिटी, इसको भी समझा है, और पहले 3 पोरोसिटी, स्पेसिफिक यील्ड, स्पेसिफिक रिटेंशन, ये इन चीजों को समझ लिया है. और स्टोरेटिविटी देखा है, स्टोरेटिविटी करके एस जो वैल्यू है उसको समझ लिया है हमने. 4 पैरामीटर हो गए. 5वां अभी कोएफिशिएंट ऑफ परमेबिलिटी अभी हमने समझ लिया, और अभी 6वां पैरामीटर जो है जिसको हम ट्रांसमिसिविटी करके बोलते हैं या ट्रांसमिसिबिलिटी, इट इज डिनोटेड बाय टी. वेरी सिंपल, is the capacity of the aquifer to transmit water through its entire thickness. What is the definition? Its definition is the capacity of any aquifer to transmit the water through its entire thickness. So therefore it is the extension of the Darcy's law. Darcy ने जो बोला कि भाई velocity is equal to k into the cross section, k into the hydraulic conductivity, and discharge Q is equal to velocity into the cross sectional area, that is k into I into the cross sectional area A. इसका ही एक्सटेंशन हमें ये ट्रांसमिसिबिलिटी या ट्रांसमिसिविटी इसको समझने के लिए मदद करता है. It is defined as the product of coefficient of permeability K of the aquifer material and the saturated thickness of the aquifer B, and is expressed in units meter square per day. ठीक है, so what is transmissibility or transmissivity of the aquifer? It is the multiplication of the coefficient of permeability K and the thickness of the aquifer through which the water is being saturated, water can be taken out. Okay, so saturated thickness of the aquifer is denoted by B, and K is the coefficient of permeability. Therefore, the transmissivity T is equal to K into B, and its units is meter square per day. Okay, K is the coefficient of permeability, B is the saturated thickness of the aquifer. Very important. Number of times such definitions are asked. Now, how it's used and what are its application or the significance, we'll try to learn in our next slides to come. So friends, all these three parameters, that is the specific yield SY, the storage coefficient S, we have seen what is S. S is nothing but the quantity or the volume of the water, either that has been taken out or that has been poured in to the unit through the unit cross-sectional area of the aquifer, maybe a confined aquifer, maybe an unconfined aquifer, by either lowering or by either raising the groundwater table or the piezometric head by the unit depth, is called as the storage coefficient. We have seen in our earlier discussion. So the specific yield, again storage coefficient, and the now learned the coefficient of transmissivity T, together fully describe the characteristics of the aquifer. And these are the three parameters, like the pathological parameters of our blood. So these three parameters describe that what is the quality of the aquifer. The specific yield more, storage coefficient more, and transmissivity more, or coefficient of transmissibility more, then naturally that aquifer will give the more of the water. So T, transmissivity, is equal to K into B, coefficient of permeability into thickness. So when the hydraulic gradients equals unity, means when I is equal to 1, the discharge is equal to T itself, because Q, why? Because Q is equal to K into I into the cross-sectional area A. Okay, we have seen from the Darcy's law that Q, discharge, is equal to, you can note down in your notebook, capital Q is equal to K, coefficient of permeability, I, hydraulic gradient, and the cross-sectional area A. Okay, so what we have just said, that hydraulic gradient is equal to 1, means the difference in level divided by the length is equal to, if it is equal to unity, then this transmissivity, coefficient of transmissivity, is equal to the discharge Q, because when I is equal to 1, then Q is equal to K into area, and the area is equal to depth when the width is equal to unity 1. Okay, because area is equal to depth multiplied by the width. So if the width is 1, then naturally area is equal to 1 into B. So area is equal to B. Therefore, the discharge is equal to the coefficient of transmissivity that has been defined here. In other words, now this is the same thing in proper words, it has been said, the transmissivity of an aquifer may be defined as, another definition of the transmissivity, as the discharge through the aquifer of 1 meter width, because area is equal to the width into depth. So the depth is B meters, small b, and the width is 1. So 1 into B means B under a unit hydraulic gradient. I is equal to 1. So therefore the transmissivity T is equal to K into B. So transmissivity of an aquifer can be defined as the discharge through the aquifer of 1 meter width under a unit hydraulic gradient. And earlier also we have seen the definition as the product of coefficient of permeability of aquifer material K and the saturated thickness. And it gives the capacity of aquifer to transmit the water through entire mass. Now the values of the T or the transmissivity, coefficient of transmissivity or transmissibility, ranges from 12 meters per day to about 1200 per meters per day, depending on the type and thickness of the aquifer. It is usually evaluated or calculated from the pumping test. हम आगे में पढ़ने वाले हैं what is pumping test. Now there is one numerical that we will try to learn, understand based on all these earlier parameters. A confined aquifer is there which has the transmissibility, that is T value, as 50 meters square per day. The slope of the piezometric surface is 0.25 meters per kilometer. That is I value. The slope of the piezometric surface is 0.25 meters per kilometer. How much water flows per day through the aquifer per its kilometer width? Okay. Such similar examples are asked in exam. Okay. So we know that transmission. Again, I will read out once again. The confined aquifer has a transmissivity or transmissibility T as 50 meters square per day. The slope of the piezometric surface I is equal to 0.25 meters per kilometer, and it has been asked to find out the quantity of water flowing per day through the aquifer per its kilometer width. Okay? So we know this formula, transmissibility T is equal to K into B. K is the coefficient of permeability and B is thickness of aquifer. The T value is given as 15 to 50 meters square per day. It has been given here. Now the Darcy's law, V is equal to K into I, and Q, the discharge Q is equal to K into A into I. Okay. Now the area of the aquifer is equal to B into the width. Okay. So area is equal to B into width. If the width is 1 meters, that is the unit width. Okay. So B into width. If this B is unit or 1 kilometer, width 1 kilometer, then the depth will be 50 meters. We have been given that transmissivity T is equal to K into B, which is equal to 50 meters square per day. Okay. If the width is taken as 1 kilometer, that is 1000 meter, then I, that is the hydraulic gradient, is equal to 0.25. Width means for the hydraulic gradient, it is, you can say, length. It is the length between two piezometers, is 1 kilometer, because it has been given earlier in the numerical that piezometric surface is 0.25 meters per kilometer. Okay, therefore 0.25, it is in meter. We have to convert per kilometer to meter. Then we have to divide it by 1000. So therefore the hydraulic gradient is equal to 0.25 meters divided by 1 kilometer means 1000 meters. So that is the I value, that is the hydraulic gradient value. Therefore discharge is equal to 50, that is the transmissivity value, coefficient of transmissivity T value 50, into the I, okay, that is 0.25 into 1000 divided by the 1000. The length, the width of the aquifer is taken as the 1000 meters or the 1 kilometer. So therefore the discharge has been 12.5 meter cube per day. So the answer is 12.5 cubic meter water flows per day through 1 kilometer width of the confined aquifer. We have taken the width of the aquifer as the 1 kilometer. Okay. So therefore the discharge is equal to, we know that discharge is equal to K into B into W into I. I value we have worked out. We have considered the width of the aquifer as equal to 1 kilometer or 1000 meters. So we know that 50 into 0.25, that is KB value. 50 is KB, K into B is equal to 50. It has been given coefficient of transmissivity. So we have taken K into B as 50. Width we have taken 1 kilometers. I we have worked out 0.25 divided by 1000. So therefore K into B, that is 50, into I 0.25 divided by 1000 multiplied by 1 kilometer width, that is 1000 meters width. Therefore per day its discharge is equal to 12.5 meter cube per day. Okay, unless and until you solve such numericals again and again, you could not understand. So I again request you to move more and more on the numericals. Also, please go through the numericals that has been appeared earlier into the exams. I have also given in my notes earlier last 3 years exam questions and some numericals. You also please search, and you can also tell me if you don't understand or you want to get solved it by me. So now we will be moving on to the next part of our discussion. That is the groundwater exploration. यानी जमीन के अंदर कहां कहां कितना पानी है ये पता लगाने के लिए कौन कौन सी मेथड है, कुछ साइंटिफिक मेथड है ना। जमीन के नीचे हमारे गांव खेड़ों में बहुत सारे ग्राउंड वाटर एक्सप्लोरेशन के लिए हम कुछ जियोलॉजिस्ट को वगैरह बुलाते हैं। कुआं खोदना है हमको तो पहले हम उससे ग्राउंड वाटर यहाँ जमीन में पानी है कि नहीं भाई उसको पता करने के लिए वी ट्राई टू यूज सर्टन साइंटिफिक मेथड्स. So what are those scientific methods? To find out the availability of the groundwater below inside the ground. That you can call it as the groundwater exploration. Explore करना है ना। नहीं तो बहुत बार जमीन के नीचे हमारे जो कन्फाइंड या अनकन्फाइंड एक्वीफर है वहां पे स्ट्राटा ऐसा है कि वहां पे पानी अवेलेबिलिटी ऑफ वाटर इज नॉट देयर एंड वी विल एक्सकवेट द ओपन वेल और द बोर और फिर उसके ऊपर किया हुआ खर्चा हमारा पूरा बेकार जाएगा। तो वो पता करने के लिए इन एडवांस द वेरियस मेथड्स वी यूज टू फाइंड आउट द अवेलेबिलिटी ऑफ ग्राउंड वाटर, that is called as the groundwater exploration. As I have told you, the purpose of the groundwater exploration is mark out the water bearing formation. है ना, हमने इसका स्टडी इन एडवांस पहले ही किया बहुत कुछ जियोलॉजिकल फॉर्मेशन का, तो हम इसके मैप्स बना सकते हैं और मैप्स बनाने के बाद में किसी को कुआं खोदना है तो वो मैप का यूज करके हम उसको यूज करके हम वी कैन एक्सकवेट द वेल, ओपन वेल और द बोर वेल. सो द exploration of the groundwater is useful for marking out the water bearing formation. जैसे हम कंटूर मार्क करते हैं जमीन के ऊपर में सेम लेवल की जमीन, सेम लेवल का ग्राउंड बताने के लिए, तो वैसे ही जमीन के नीचे में पानी की अवेलेबिलिटी कितने डेप्थ पे है वो यदि पॉइंट हमने ज्वाइन किए लगे तो हम उसको ग्राउंड वाटर टेबल के पॉइंट बोलेंगे, ग्राउंड वाटर कंटूर भी बोल सकते हैं, तो उसको हम बोलते हैं, उसको बोलेंगे ग्राउंड वाटर बेरिंग फॉर्मेशन का पता करने के लिए. एस्टिमेट देयर हाइड्रोलॉजिक कैरेक्टरिस्टिक्स ऑफ दिस ग्राउंड वाटर फॉर्मेशन. जो भी एक्वीफर्स है, कन्फाइंड है, अनकन्फाइंड है, तो उसके हाइड्रोजियोलॉजिक कैरेक्टरिस्टिक्स यानी उसकी परमेबिलिटी है कि नहीं, अवेलेबिलिटी है क्या, फ्लो होता है क्या पानी, ये पता करने के लिए एक्सप्लोरेशन कर चलेगा. और तीसरा और बहुत इंपॉर्टेंट है ना, बहुत बार ऐसा होता है कि हम बोरवेल या कुआं खोदते हैं और उसमें का पानी बहुत पीने लायक नहीं होता है, उसमें बहुत सारा सॉल्ट रहता है या एक आधी बार फ्लूराइड रहता है. बहुत सारे हमारे विदर्भ में भी कुछ एरिया है कि उसमें ग्राउंड वाटर में फ्लूराइड है और वो फ्लूराइड दांतों के लिए बेकार है. या बहुत सारे जगह पे वो पानी में कुछ ज्यादा अल्कलाइन रहता है, कुछ ज्यादा एसिडिक रहता है, कहीं कहीं तो पानी में सॉल्ट रहता है बहुत सारा, है ना. कोई अभी मुझे अपने एरिया में कुछ गांव है कि वो ग्राउंड वाटर में बहुत सॉल्ट है, तो वो गांव के लोगों को किडनी प्रॉब्लम है क्योंकि वो किडनी हमारे फंक्शन करती है सॉल्ट निकालने का, किडनी के ऊपर लोड आता है. तो इसलिए इन एडवांस we can get the quality of the water that is available underground. For that purpose, we perform the groundwater exploration. What are the various methods of the groundwater exploration? है ना, जमीन के नीचे पानी की अवेलेबिलिटी, क्वालिटी ऑफ द वाटर, क्वांटिटी ऑफ द वाटर and the permeability of the strata. Three things are very important. The quality of the water means whether that water is drinkable, usable for the agriculture purpose, and also usable for the industrial purpose, etc. The second is the quantity, क्योंकि इतना खर्चा करेंगे तो पानी समूचे मात्रा में मिलना चाहिए हमें, quantity of the water, as well as the permeability of the strata, not the porosity. Porosity तो है इसलिए तो पानी है, लेकिन उसमें से पानी बहता है कि नहीं, या पानी इजीली निकाल सकते हैं कि नहीं, पंपिंग से भी निकालना है तो उसके लिए हमें ये एक्सप्लोरेशन करना पड़ता है। और उसके जो हमारे पास में अभी फिलहाल 4-5 मेथड अवेलेबल है। एक है रिमोट सेंसिंग से पता चलता है, आजकल हमारे पास में बहुत टेक्नोलॉजिकल एडवांसमेंट बहुत है, तो हमारे सैटेलाइट वगैरह सब दे आर सिचुएटेड at the kilometers together above the earth surface, from where with the help of the microwaves etc we can very easily find out the quantum and the quality of the water that has been available below the ground surface, है ना। आजकल ये रिमोट सेंसिंग से हमें वाटर रिसोर्सेस का बहुत अच्छे से पता चलता है। दूसरा है सरफेस जियोफिजिकल मेथड, the electrical resistivity method and the seismic refraction method. एक है वेल लॉगिंग मेथड, इसका ही वेल लॉगिंग मेथड यानी जो एग्जिस्टिंग वेल है, एग्जिस्टिंग जो कुएं है, मे बी ओपन वेल, मे बी ए बोर वेल, तो उसकी जो ग्राउंड वाटर टेबल साल में या पिजोमेट्रिक हेड ड्यूरिंग द ईयर, ड्यूरिंग द पीरियड ऑफ द ईयर, हाउ मच दोज लेवल्स vary or the changes. If we try to measure it down, if we try to record that data, and if we, और एक ग्राउंड वाटर टेबल के मैप भी है, वो भी बनाए जाते हैं वाटर वेल लॉगिंग मेथड से, है ना। वो मैपिंग के ऊपर में एक आध बार शॉर्ट नोट आती है एग्जाम में, ठीक है। तो ग्राउंड वाटर मैपिंग हम जैसे यहाँ ये पढ़ते जाएंगे तो इसमें समझते जाएंगे। और टेस्ट ड्रिलिंग, एक आधे बार क्या है कि हम समय के ऊपर में, समय यानी हमारे पास में ये तीनों मेथड से कुछ अवेलेबल नहीं है कि ये लोकेशन में पानी है कि नहीं ग्राउंड वाटर, देन इन दैट केस वी कैन वेरी इजीली फाइंड आउट बाय द ड्रिलिंग द बोर, उसमें छेद करना जमीन में, और वो बोर को ड्रिल करते करते गए तो हमें पता चल सकता है कि कितने डेप्थ के ऊपर में पानी अवेलेबल है। तो दोस्तों जितना भी हमारे पास में अभी 5-10 मिनट समय है, हम उसमें जितना कवर कर सकते हैं विल ट्राई टू कवर, सो दैट द रिमेनिंग पार्ट जो है, और मुझे लगता है 1 या 2 लेक्चर लगेंगे इसको, क्योंकि वेल हाइड्रोलिक्स करके पार्ट है, बहुत इंटरेस्टिंग और इम्पोर्टेंट पार्ट है, उसके ऊपर भी न्यूमेरिकल्स आते हैं, उसको समझने के लिए हमें 1 या 2 लेक्चर और लगेंगे। तब तक इसमें जितना होता है उसको हम फिनिश करते जाएंगे। 4 मेथड हमने अभी देखा, एक रिमोट सेंसिंग, सरफेस जियोफिजिकल मेथड, इसमें इलेक्ट्रिकल रेजिस्टिविटी मेथड, सेस्मिक रिफ्रैक्शन मेथड, वेल लॉगिंग। वेल लॉगिंग मेथड में हम वाटर टेबल मैप्स भी पढ़ेंगे, मैपिंग, वाटर टेबल मैपिंग, और फिर बाद में टेस्ट ड्रिलिंग करके है उसको समझते जाएंगे, है ना। मैंने बताया वैसे इसके ऊपर हर साल कहीं ना किसी ग्राउंड वाटर एक्सप्लोरेशन के ऊपर में नोट्स आती है आपको। Remote sensing, as I have told you, we have numerous in our India. We are very proud nowadays that we have ourselves produced, prepared the numerous satellites. We can on ourselves indigenously propel or put these satellites into the orbit above the earth with the help of the सैटेलाइट लॉन्च व्हीकल्स। हमारे खुद के लॉन्च व्हीकल है, हमारे खुद के सैटेलाइट ले जाने वाले यान है, और उससे हम वो सैटेलाइट को आराम से जो ऑर्बिट में हमें रखना है उसमें रख सकते हैं। तो इसका उपयोग हमने जो सैटेलाइट्स का है ये हमारे हाइड्रोलॉजी या जियो हाइड्रोलॉजी के लिए बहुत अच्छी तरह से किया है। हमारे नागपुर में एक जो वीएनआईटी है ना, आप सबको मालूम है, विश्वेश्वरैया नेशनल इंस्टीट्यूट ऑफ टेक्नोलॉजी, तो उसको लग के ही एक गवर्नमेंट ऑफ महाराष्ट्र का एक सैटेलाइट इंफॉर्मेशन सेंटर है, या सैटेलाइट से रिमोट सेंसिंग सेंटर बोलते हैं उसको, रिमोट सेंसिंग लैबोरेटरी। एक आध बार हम जाएंगे नेक्स्ट सेमेस्टर में, जब आएंगे तब एक टेक्निकल विजिट जरूर हम वहां पे जाएंगे। तो वहां पे सैटेलाइट से हाउ द ग्राउंड वाटर has been explored, that you can see very well. They have got very good exhibition cum explanation center, very adjacent to VNIT Nagpur. So with the help of the aerial photographs, again aerial photography and satellite से ली हुई photography, imaging, again the photographs with the help of the infrared and the radar images, and the low frequency electromagnetic aerial methods, they are included in remote sensing methods. मैंने अभी आपको बताया रिमोट सेंसिंग लैबोरेटरी है यहाँ पे, गवर्नमेंट ऑफ महाराष्ट्र की है, नॉलेज सेंटर करके वीएनआईटी के पास में। The remote sensing methods of the groundwater exploration with the help of nowadays all these satellites by the aerial photography, infrared and the radar imaging, and the low frequency electromagnetic aerial methods, we can very well explore the groundwater availability. Along with this, the other hydrological parameters which can be very easily calculated and found out are the precipitation, that is the rainfall. हमने रडार का यूज देखा ही है प्रेसिपिटेशन में, फाइंडिंग द प्रेसिपिटेशन इन द विद द हेल्प ऑफ द रडार। तो हम ये तीनों भी मेथड से प्रेसिपिटेशन, इट्स इंटेंसिटी, इट्स ड्यूरेशन and its distribution, wide distribution over the catchment area can be found out. The evapotranspiration, interception, infiltration and the runoff can be found out, can be inferred from the aerial photographs by mapping the water area, the geology, soil type, seepage areas, vegetation covers and many other features. Satellite photographs can also be used for this purpose. So very effective use of the satellite photographs is nowadays very accurately done to determine in advance and also for the present situation the finding the various hydrological parameters like the groundwater availability and the other precipitation, evapotranspiration, etc. Numerous developments are there. Infrared imagery is sensitive to differential head capacity of the ground and can map soil moisture, ground movement and the faults. है ना, अभी तो ये सैटेलाइट से हम ये जब पानी का पता कर सकते हैं तो जमीन के नीचे कौन से मिनरल्स है, यानी कहीं गोल्ड है, कहीं आयरन है, कहीं और कोई एल्यूमिनियम है, सॉइल के नीचे ग्राउंड वाटर मूवमेंट है, फॉल्ट्स है, ऑल दिस थिंग्स विथ द accurate depth we can find out. We have nowadays these all recent developments are there. Non-visible portion of the electromagnetic spectrum gives all these things, that is this which helps in this several imaging techniques, okay, which we can call it as a infrared imagery, है ना। अभी हमने क्या देखा, एरियल फोटोग्राफी, इंफ्रारेड एंड द रडार इमेजिंग एंड लो फ्रीक्वेंसी इलेक्ट्रोमैग्नेटिक एरियल मेथड्स, उसका ही कंटिन्यूएशन में इंफ्रारेड इमेजनरी इज, यानी इंफ्रारेड अर्थ के ऊपर प्रोपोगेट किए जाते हैं वो रिफ्लेक्ट होके आए, तो वो रिफ्लेक्ट होने के बाद में उसकी जो भी रिफ्लेक्शन के इमेजेस है उसको वो बराबर कैलिब्रेट करते हैं कि जमीन के ऊपर में या जमीन के नीचे क्या क्या है भाई, जंगल है क्या, पानी है क्या, कोई मिनरल्स है क्या, ऑल दिस थिंग्स. रडार इमेजरी वर्क्स इन दी 0.01 टू 3 मीटर्स. उसकी जो वेवलेंथ रेंज रहती है उसके और डिटेल है ये टेक्निकल. 0.01 to 3 meters wavelength range and can penetrate vegetation cover to provide subsurface information such as soil moisture at shallow depth. है ना, यानी जंगल भी है तो जंगल को भी पेनिट्रेट करके ये जो रडार के जो ये वेव्स है वो इसमें से पास हो सकते हैं. इसकी वेवलेंथ दिया है. बरीड सब सरफेस चैनल्स, यानी जमीन के नीचे यदि कोई पानी बह रहा है जिसको बरीड यानी जमीन के नीचे का पानी बोलते हैं, बरीड सब सरफेस चैनल्स एंड सॉल्ट वाटर इंट्रूजन फ्रंट्स कैन ऑल्सो बी सक्सेसफुली लोकेटेड बाय यूजिंग recently developed aerial electromagnetic exploration methods which operate in the frequency range of 3 to 9 kilohertz. ठीक है, तो अभी हम यहाँ पे टुडे विल बी टेकिंग द ब्रेक. द रिमेनिंग पार्ट दैट इज सरफेस जियोफिजिकल मेथड जिसमें इलेक्ट्रिकल रेजिस्टिविटी मेथड और सेस्मिक रिफ्रैक्शन मेथड है, और जो भी और बाकी बचे हुए दो मेथड्स है by the drilling bore holes as well as by logging the existing wells and mapping the groundwater table. ये हम अभी नेक्स्ट इसमें पढ़ेंगे. और उसके नेक्स्ट इसमें फिर से समय रहा उसमें तो फिर वेल हाइड्रोलिक्स और सम डेरिवेशन, some concepts of the well hydraulics and some numericals.